Morning, everyone. You can give me a thumbs up if you can hear me. Okay. All right, I'll hand it over to you, Rick, to get us started and do the introductions.
Perfect. Well, thanks everyone for joining us. This is a first event that we're trying out here, and we are planning to do some more of these. So at this point, we're planning to do them on the last Wednesday of every month, and the idea is just to give people some practical tips and tricks about working with an oil analysis program and maintenance and reliability. So we'd like to share some of the experience that we've gained through the years. And just a quick introduction about myself. So I work with Clausen Advanced Filtration, and we sell filtration equipment made by CC Jensen. We serve Canadian customers right from coast to coast, work in all major industries. And myself, I did mechanical engineering at BCIT, and I've been working with oil and filtration now for over 20 years. And I'm pleased to have with me today Brian Harris. And Brian, I'll let you introduce yourself.
Oh, thanks, Rick. Yeah, I'm Brian Harris. I'm the owner of Tribler Consulting. I'm a certified MLA 2. I've 15 years oil analysis experience, 15 years looking at oil sample results. Not every day. I do take a weekend off and sometimes take a vacation. And I've lots of experience implementing and developing oil analysis programs.
Excellent. So just a couple of things about the webinar here. There are some interactive elements. So you'll see there's a chat box at the bottom right. So you can feel free to pop a message in there. If you just had general comments or whatever. If we're going to have a couple of polls, so you'll see the poll button there, and those will pop up, and you can just mainly just a check to make sure that you're still awake, but you can pop your answer in there and submit it. And if you want to try out the chat box, you can let us know where you're joining us from today. I saw quite a few names on the attendee list. So yeah, just again, thanks for being part of this. We are going to record this, so hopefully we'll make it available for sharing after the fact if there's someone else you think might benefit from watching that. If you have any questions, there's also a question button there, and you can type your question in there. We'll probably maybe save, if you had something come up and you want to just ask a question on it, go ahead. Or if you want to save it to the end, that's fine too. And we'll sort of take it from there. So I think that's it for the kind of the layout of things. So the contents of what we're going to go through today is regarding oil analysis, and I think everybody would accept that it's, in theory, it's a great thing to do. In practice, well, what does that actually do for you? And that's where we want to give you some tools to take what you're getting from the analysis program, what you're putting into it. If you're sending people out to collect samples and you're compiling results and looking at data and having spreadsheets and charts and all the rest of it, and the question is, what do you do from there? Where do you go from there? How do you turn this into something that's going to provide value back to you? And so Brian has some really practical experience, not just using the systems, but he's also been kind of instrumental in setting up some of the tools with the analysis systems as well. So he really found a way to leverage the data that was coming in and turn it into something that can be really useful for making, getting a return on your investment with the analysis program. So I'll turn it over to you, Brian, and we can get underway here.
Okay, thanks, Rick. The first slide is pretty self-explanatory. obviously, as you can see, it leads to unreliable operations. And I think if you've ever worked in a heavy industrial environment, you'll know what unreliable operations looks like. I certainly do. So the question we should ask ourselves is, what is an ineffective oil analysis program, and how do you know it's effective or ineffective? So that's the kind of gist of this webinar, is how you measure it, what KPIs you should be looking at to determine whether you have a effective, or more to the point, an ineffective oil analysis program. So the last line, unreliable operations, I've worked in many industries, varying degrees of reliability. As a reliability engineer, reliability specialist, manager, and a lubrication program manager. And there's lots and lots of failures related to lubrication, and the vast majority are unavoidable. So unreliable plants are generally stressful. Loose production, heavy maintenance costs, high turnover, all those things which are, for want of a better word, undesirable. So I think we have a poll here. Perry, do you know? Can you submit the poll?
It looks like it should be submitted there. I'm not sure what it looks like on their end. They probably have to click on the poll button on the bottom right.
So if you click on the poll button, it's a simple question. Most PM programs are ineffective and wasteful. In my experience, they are. So just want your opinion on whether you agree or disagree with that. So if you can take the time to answer the poll.
So far, it's unanimous agreement on one side.
What would that be?
7-1. Most PM programs are ineffective and wasteful. 7 say agree, 1 says disagree so far.
So I would love to work at that plant that has a reliable operations. But let's move on. This is a slide I tend to show it in every presentation, every KPI review that I do it. It's a reminder for people who don't understand what contamination does to your equipment. ISO, water, ISO count is basically levels of dirt in your equipment, and water is self-explanatory. It doesn't take a lot of water to make a significant impact on your equipment health. 0.1% is what the class is severe, but if you even have 0.05% of water, your oil will look normal, but it will reduce the life of your bearings by 50%. So significant impact on life of equipment, production, reliability. What Rick mentioned was, if you have any questions during the presentation, feel free to ask them, then we can kind of answer them as we go along. So that's contamination effects. Again, I think most of you would have seen these graphs, but quick reminder of, oh, I should add, I find that 95% of your oil analysis issues, your alerts, your abnormal results are related to contamination effects. The other 5 or 10% are usually the contamination effects contribute to those as well, whether it's wear metals, oxidation, acid levels, all those other types of things which are undesirable. So for those of you who haven't seen an oil sample result or report, this is what one looks like. Lots of columns to look at. The classifiers, wear metals, additives, contaminants, physical tests. A couple of things to be aware of. Wear metals could be additives, and additives could be wear metals. So zinc could be a wear metal, it's also an additive. Wear metals, titanium is an additive, but it's listed here as a wear metal. And also contaminants, things like silicon could be an additive because they put that in as an anti-foaming additive. So lots of things to look at, and this is a basic test. There are additional tests you could ask for, especially turbine oils, which require things like NPC, RV pot, those types of tests. So a lot to look at.
Hey, Brian, just something on that slide. At the bottom, there's the key where some of the results might show up with different colors. and those would be considered flags. Now, this particular sample doesn't have any flags. That doesn't mean actually that everything is great. So how do you work with that to maybe set up specific flags, maybe for cleanliness or a particular additive
That's a great question. That's a great question, Rick, because some of this isn't self-explanatory, and that's essentially why you need an analyst to look at the data and tell you what it's saying. For example, this one, it's not flagged, but it's got calcium as an additive at 13, which really shouldn't be in the oil that's in use, because it doesn't show up in the reference sample. Plus, it's gone from a 1 ppm to 13 ppm. So I don't want to get into too much detail about analysing this data, but that's why you do need an analyst with some experience, preferably with a certificate to demonstrate he's competent, to look at the data and make some determination on whether it needs further follow-up. So certain things do get flagged, like water content is a general flagging rule of 0.1% being severe. ISO counts, the base, those flagging limits on industry standards. So I've seen ISO count codes of 24, 25, which don't get flagged because industries generally run their oil dirtier than recommended. So when you get into a 26, 27 range, I'm talking about 4 micron range for ISO count, then these labs start to flag that as severe. Well, personally, I think that's way too high. Even OEM recommendations don't suggest you run your equipment that high a level of ISO count. So good question, but there's lots to look at in an oil sample result, and you can't just assume that the lab is going to give you good advice to address what those issues are. That's the role of the analyst. But I've talked again about ISO code recommendations. This is if you Google this and look at what's the ISO code recommendations for particular types of equipment, this is hydraulic systems. This is an old ISO code recommendation because it's only got the 2 digits, but it's reckon anywhere from 13 to 21, which is going, what does that mean? It's a bit ambiguous, to say the least. So this is a more up-to-date ISO code recommendation. Again, it's ranging from anywhere to 20 to as low as, I think there's one that says 13 down there, to 15 ISO count. So again, it's a bit ambiguous. You've got an ISO count recommendation. And when I talk ISO count, I'm also talking about the first number. That's the 4 micron range. So anywhere from 20 to 15. I've never seen an hydraulic system that just has a pump on it and doesn't have anything else. So why would you run your ISO levels at a 20 when the flow control valve or the servo valve requires a 16? So always try and target the lowest ISO level for the system. So forget about what's on the internet. It's all good information normally, but these just confuse the hell out of people. So my rule of thumb is if you've got an hydraulic system, you should try to attain an ISO code of 16 or less. For a lube system, a reducer, try and obtain an ISO code of 18 or less. You're not always going to achieve that, but that should be your target. And if it's 19 or 20, it's not going to do a lot of damage, but once it starts getting up to 21, 22 and higher, then you want to think about lowering that ISO count, using generally speaking, an offline filter unit. Let's get into KPIs now. So I try to use a SMART principle for KPIs. And if KPIs, key performance indicator, I'm sure most people on here will know what that stands for. But I use the SMART principle for KPIs: specific, measurable, attainable, relevant, and time bound. So to achieve those types of improvements and see it in your data, there's basically 5 simple steps you should take. 5 simple steps shown on the left. And for whatever reason, I haven't got a good answer for it, but companies struggle with, first of all, the first one, taking a sample, right? Which sounds easy enough. And the secondly is taking a sample that's representative of what's in the system. Generally, they take bad samples. But then you get into and when we get into the examples of KPIs, it's step 2 and 3. 3 being the obvious one, assign a relevant task to correct the issue. Now you've got to identify the issue and do the corrective action to make those improvements. So it does sound simple. It's a 5-step process, but for whatever reason, lots of companies struggle with this. So this is a test breakdown comparison. I'll try to explain this. The 2 separate industries, one on the left, one on the right. I would ignore the numbers that are written in the boxes because the one on the right takes 7 times more samples than the one on the left. But when you look at these are samples returned with severe issues. So if you look at the one on the left, it says 432 samples returned with severe water contamination, right? The one on the right, the top one is viscosity at 100 degrees C. Now, there could be a number of reasons why that is, but the water ranks high in both of these plants. Different industries, different product at the end that comes out of the end of the door, but they both got the same issues. And they also rank highly in dirt contamination. So what do you do to make improvements? So this isn't a KPI. It doesn't follow the SMART principle. But what it does do, it gives you data to focus on those issues, whether it's water contamination, high ISO count, to make those improvements. So you can measure, once you start making those improvements, to see how those improvements materialize over time. So for 2 years, you've got 15% of your samples returned with water contamination. What does the next 2 years look like? What's the next 2 years look like? You've addressed those issues. You've got better contamination control. You're removing the water from whether it's an hydraulic system, lube system, or reducer. You're lowering the amount of dirt. You're lowering the wear on the equipment, the wear and tear, and you're making those improvements. And you'll see that in your data once you start putting these actions into place. So it's useful data, but it's not essentially a KPI related to wall analysis. I'll go back to this slide. So I said about focus on underlying issues. That previous slide, I had lots of issues with viscosity, and I do know because I've looked at the data. A lot of it is database issues. A lot of it is the change you all haven't changed a reference sample, that type of thing. But in a lot of cases, they've got issues with oxidation. They've got aged oil, they've got dirty oil, and they're basically taking sample after sample and not addressing the issue. And if you can't remember what oxidation looks like, it looks like a big yellow blob with brown things in it. And these are the things that create oxidation: heat, dirt, wear metals, water, and lastly age. The longer you leave it, the worse it's going to get. And if you haven't experienced varnish, it's never good. And varnish is a result of oxidated oil. There's good varnish and bad varnish. Good varnish is the type of stuff you paint the fence with. The bad varnish that attaches itself to bearings, lube lines, and all those types of things is extremely what's the word I'm trying to look for? I should have rehearsed this, shouldn't I? It's extremely destructive. It's extremely destructive, and it creeps up on you. The vibe guys won't pick up on it. They'll just see the failure. I've seen this many times where equipment just starts to fail because the varnish just says, "I've had enough. I'm shutting you down." It's like having a severe heart attack, and it's extremely difficult to get rid of, and it's expensive. It's energy consuming. It's just, and if you don't look at your oil analysis data and react to what it's telling you, guaranteed to have varnish. I've had numerous occasions, and I'll quickly mention this. We will be doing other webinars in the future, but the next webinar is going to be about case studies, and in those case studies, there'll be a couple of examples of what varnish does to your equipment, but totally avoidable. So let's get into some KPIs. This is a KPI which demonstrates program growth. I'll quickly explain it. If you look at the blue boxes per equipment, like worm gears, hydraulics, lube tanks, reducers, that's data from 2019. That's how many components were sampled on that piece of equipment. Previous to that, in 2018, there was no samples taken. This was a plant that didn't have an oil analysis program. So you start small. The next year, you expand the program to other areas of the plant, and then you build on that. So the intent was, year on year, you want to expand the program by at least 10 to 15%. The more components sampled, the more components in the program, the more you'll save. So a couple of things: hydraulics, lube tanks, bulk systems should definitely be in the program. Reducers, you can add them as you go along. Don't worry about criticality, just get as many in the program as you can. If you have enough resources, and generally a lot of companies don't, you could start sampling pumps, especially critical pumps, which have an impact on production if you lose them. But this company never got around to that. That's program growth. So let's get into the nitty-gritty of this, the KPIs we want to present to management. This is a cost-benefit KPI, and without a doubt, the most important KPI you can present to management, because this demonstrates cost savings associated with fixing those issues you've identified in an oil analysis program. So you see, over time, this company plant saves about $1 million a year on corrective actions associated with abnormal oil sample results. It justifies spend on the oil sample program. If you're spending $80,000 to $100,000 on an oil sample program, and you're investing money and time and effort into correcting those issues with offline filters and upgrades to equipment, that all takes time and effort, and you need the money to do that. So you go to your general manager and say, "I need $20,000 for this, and this." If he doesn't see the data, the return on the investment, it's unlikely he's going to approve that spend. So this gives a demonstration of cost effectiveness, for want of a better word. I'll explain the red line later. There's a reason why it's going up like a helter-skelter at the moment.
Ryan, when you're compiling the returns, so the benefits that you're getting from the program, in terms of like real dollars, I mean, you'd be looking at things like how much oil you saved, maybe how fewer, maybe you've had less replacements in that time, and disposal costs. So like, how would you prioritize those various returns and say, well, this is going to be the easiest to calculate, so we'll put that in. This is going to be more difficult to calculate.
Ross, if I understood the question, Rick, is how do I come up with these numbers?
How do you demonstrate the real dollars that you can say we spent $100,000 on the program, but it saved us $1 million? So
I've been asked that question numerous times, and I did develop a couple of slides to explain where I came up with the numbers. So I base it on a life extension of a $50,000 gearbox. So basically, if I have a gearbox and I fill it full of dirt and I add a bit of water to it, how long is it going to last? So this goes back to the slide where I show about life expectancy. So it's all empirical data bearing companies have assessed this and said, if you, obviously the cleaner, dry your oil, the longer it lasts. So rule of thumb is, I usually say, I've extended the life of the equipment by double. So that $50,000 gearbox now costs me half as much a year in annual cost than it did if I go from 10 years to 20 years. So I'm probably not explaining this very well, but everything is underestimated. I base everything on a $50,000 gearbox. And when I get pulled up about it and say, you've got gearboxes in this plant that cost $250,000. You have hydraulic systems in this plant that cost $1 million, $2 million, like that large bulk lube system. So if I'm just correcting an issue with an oil sample result, a corrective action, whether it's putting a filter on it or changing the oil because it's oxidized or anything like that, I put $5,000. And when I explain that to your C-suite people, your senior managers, your general managers, I say, this is a number I came up with. They don't question it. But when they look at the number in a chart like this, they're going, well, I know it's probably 2 or 3 times more than that. Right? So that more than justifies the cost of the oil sampling program. It more than justifies the cost of filters and all that other good stuff. I hope I've explained that.
Yeah, that's great. And I think you touched on something really valuable in that, you know, we're often looking at making improvements and realizing a life extension, but the opposite is also just as real. And say if you have a gearbox reducer with a 15-year design life and you're running it at an oil cleanliness that's 3-4 times above spec, you're going to actually cut the life of that gearbox in half or worse. Yeah. So instead of 15 years, you might actually be expecting 6 years. So that life extension goes both ways.
Well, I'll get into this in the next webinar about case studies, because there's a plant which we'll talk about, which had gearboxes which were massive. You know the ones I'm talking about? The ones that are all like 1,000 litres of synthetic oil. The design of that plant was 40 years, right? And these gearboxes, they didn't have a bunch of replacements in the warehouse. They're expensive. They're $1 million plus for a gearbox. You want that gearbox to now last 40 years, right? So you can't be filling it full of dirt and adding a bunch of water to it and expect it to last 40 years. You've got to maintain the lubricant that's basically it's extending the life of it. So 40 years is a long life for a gearbox. And in that particular industry, it isn't that common. So things were done ahead of time before the plant started up to make sure that the plant, the equipment, the critical equipment would last for 40 years. But I'll get into that more in the next webinar, but good conversation. I'm cognizant of the time here, so we've only got an hour, so I'll press on. So some of these KPIs I'll go through pretty briefly because I want to get to the end where we get to look at some of the samples. So any predictive program, whether it's inspections, ultrasound, vibration, oil analysis, needs to be finding issues and generating work. So this is tasks from alerts. So when you get an abnormal sample result back, you generate a task. Now there might be multiple tasks to a work order, but at the end of those are the tasks that you're gonna do to address the situation. If you're doing, I'll get into this later, but if you're doing hundreds of thousands of samples and you're not identifying any issues, well, you've got a problem. It's you've got to tailor the program that you're actually identifying the issue and correcting it. So from those tasks, like I said, you might have 3 or 4 tasks in a work order. You've got to complete all those tasks for the work order to be closed out. So again, when you're starting from scratch, you may not have the equipment to be able to filter a piece of equipment. I should stop there because I should reiterate why I recommend filtering. If you believe that, and we should have had this as a poll because it's a good question. If you believe just changing the oil in a reducer or a piece of equipment eliminates all the contaminants, whether it's water or dirt, right? If you believe doing that is the right thing to do, you're wasting time and money. Because as you drain that oil or you drain that lubricant out the equipment, you're probably leaving a fair proportion of it still in the system. As soon as you turn a reducer off, all that dirt just falls to the bottom of the reducer. So draining the oil isn't going to get it all out. A lot of it just stays in there. So you put your fresh oil in, you start it up again, and you wonder why it's still got water and dirt in the system. So you need to be able to filter that out while the system's running. But you may not have the connections or the ability to do that while the plant is running. It's best to do it, obviously, while the oil is warm and the plant's running, and then you grab all the dirt and filter it out. So the other thing is, you might not have enough filter units. This particular plant had, probably 5 or 6 offline filter units when we started the program. None of them worked. They were basically stuck in the corner, covered in dirt. Really weren't that practical. When you start with one unit, you demonstrate that works, and before long you're buying more and more. So that's why when you look at 2020, it's taken you on average 3 months to complete the work order, whether it's upgrade the unit so it can be filtered, and you have enough filters to actually do what you're trying to do. You're being proactive. So I say there, and I'll say this a lot, is the longer you leave it, the worse it gets. The longer you leave equipment with dirty, contaminated, wet oil in it, the more damage you're going to do. But if you don't take oil samples, you won't identify this. So another one is average sample acknowledged time. I see a lot of companies, not a lot, some companies take an oil sample, send it out, it comes into the database, and nobody looks at it for sometimes months on end. So if they're not looking at the data and doing the action, what's the point in taking the sample in the first place? So this particular plant used to take a week or so before some guy would look at the data and then action it, and then eventually brought it down to 2 or 3 days. It should not take you more than a week to go through your sample results, identify the problem, put in the corrective action, and complete the tasks. So what I like to say is pull the sample. Usually within a week you get the sample back from the oil lab. The analyst looks at the data. If it's good, you just acknowledge it. If it's bad, you put in the tasks or work order, what they call a reliability alert. And within 2 weeks, you should be able to complete that task. Generally, I'd say 90–95% of the time, it's hook up a filter, clean it up, and then move on. Occasionally, you might have to dump the oil if it's really bad, if it's severely contaminated, or you might have to do a power flush or high velocity oil flush, something to get those contaminants out, if you have that equipment.
Brian, there's a question about what's happening in 2024 to see that start going up again.
Well, I'm not allowed to say.
Maybe Lauren's onto something there. Maybe somebody left who had some valuable input.
So I don't get too hung up if it's like 3 or 4 days before some. This is in total. So if you've got 1,000 sample results, right, and on average, if you're taking 3 days to look at the sample and then correct it, right, that's really not bad. But when I get into some of these other examples where nobody actually looks at the sample or does the corrective action, that's bad. That's really, really bad, right? So what I try and target is less than a week to look at the data, do the acknowledgement, and move on. But
Brian, would it ever happen where there's multiple people with access to the account, one person acknowledges it and then doesn't tell anyone and does nothing about it?
Yeah, I've actually experienced that. Is when I worked a back-to-back job, and I had like an opposite number, looking at data. I was looking at data. And you've got to trust the guy who's doing the job. But as a backup, I would basically do a data dump of all the oil samples. Not that I was spying on him. I would do a data dump of all the oil samples that would be acknowledged on the time I was off. And then I'd quickly go through it and go, I agree, disagree, whatever. And he would do the same thing, right? So you kind of communicate and get that rapport that you're both on the same page on what's required and follow up or not. And the other thing is, when you're generating alerts, especially with this Fluid Life MyLab program, it sends out emails to everybody saying, this is the alert, this is the corrective action, this is the work order. So there's lots of communication if you set the program up correctly. And that's quite easy to do. So we're going to alarm component percent. So this is an indication of, like I said, back in 2019, didn't do a lot of samples, wasn't really a lot of issues. 2020, expand the program to the rest of the plant, you start to pick up a lot of issues. And I will say the flagging limits for Fluid Life are pretty lenient. So it might look like you've got 67% come back as normal, when in fact, actual fact, it might be a lot more. But what it shows is over time, you've progressed, you've made improvements. You've gone from, forget the first year, wasn't many samples, you've gone from 67% to 78% of normal. But more importantly, your critical samples, your normal samples have gone from 13% to 7%. So I updated this based on 2025's data so far. This is 7 months into the program. So this company is now running at 87% normal and only 3% as critical. So when you go back to 2020, 13%. So that's a huge improvement, which kind of highlights what I've just been talking about finding the issue, correcting the issue, and moving on. So this is a dashboard which shows numerous KPIs. So I'll talk to a few of the issues. If you look at the samples, again, you can see the program building up, and I'm surprised somebody has asked the question yet of why it's kind of dropped off in the last 2 years. The reason for that is, as you build a program up, and what I like to do is if they don't have any data, I'd like to sample equipment on a monthly basis. I want some trends, right? So I've got trends. I've identified what the issues are. So I'm pulling samples on a monthly basis. Once I've corrected those issues, you've got desiccant breathers, high quality desiccant breathers. You're systematically filtering the equipment. In certain cases, you might have what's called a HSD, a humidity humidifier on it. So if you've got gross water contamination, that type of thing. So what you generally do is you've got evidence-based maintenance going on here. You're going, I'm not going to do it monthly. I'm going to start doing it every 2 months because I'm quite comfortable that within that time period, there isn't going to be anything malignant or severe going on with the sample result. Then I get to 2 months, and I might extend it to 3 months. And I try not to go to 4 months, but if it's not super critical, doesn't have an impact on production, then that's maybe what I do. So what I'm saying is, you lots of samples, sample every month, and then you tailor them off. You just focus on you want to, if you like the term bad actor, I'll call them bad actors, the repeat offenders, if you want to call it that. So that's why you're seeing a reduction in samples and an increase in percentage of ranked samples, because you're basically sampling more of the equipment that's giving you problems, right? Does that make sense? So this is, generally speaking, what your KPI dashboard should look like. So now we're going to a dashboard. This is what it shouldn't look like. This is
To interrupt you, Brian.
Yeah.
There was a question in the chat, probably about the previous slides. So as the program progresses, did the company realize decreased maintenance costs or improved uptime directly associated with this?
That's a good question. Short answer is yes, but it was all subtle. It was comments like from maintenance supervisors, and I've said this story before. He said, well, we used to change 2 of these reducers every shutdown. We haven't done that for a while. Why is that? And I'd say, well, go and talk to the oiler and she'll explain it to you. So it's subtle things that over time, you're extending the life of your equipment, you're seeing less failures, you're seeing less equipment replacements. But I'll get into this in another slide when I get to the end of this. It's a huge impact on production, right? So it's all kind of, it happens under the radar, so to speak, and it'll take years before you start to notice it. This is not going to happen in 2 or 3 months. If you haven't filtered equipment, you haven't got high quality desiccant breathers on things, and you haven't sampled equipment, you don't know what the lubricant looks like, you can't, the damage is already done. So it takes time for that to filter out, excuse the pun, all those damaged, broken equipment that's going to fail anyway. But you also, as you're doing this, you're extending the life of the equipment that's already in use. And it shows in your oil sample results. But it also shows in your maintenance costs, and more importantly, in your production. And I'll get to that in another slide. So that's, I don't know whether I answered that question or not, but that's how I would explain it. What I'm saying is it's subtle. So example 2 is not what your oil sampling program should look like. That this company doesn't use tasks, doesn't use work orders. In some cases, but I know from experience, they never acknowledge sample results. But to be fair, they don't take more than 40 samples a year anyway. So essentially, and the samples they do take are horrendous. I think they don't achieve more than 50% of normal. So essentially, this company doesn't have an oil sampling program. It's not ingrained in the culture. And I do know from experience that this company runs from one failure to another, right? It's a highly reactive environment. And when I went through this plant with a reliability engineer and explained him how to do all this, at the end of the week I was with him, he said, I don't think I've got time for all this. The poor guy was a reliability engineer. He's running the lube crew. He's running the VARD crew. He's doing all that other good reliability stuff, managing the PM program. And he's working 12 hours a day, 6 days a week to try and keep up. And he said, I don't really think I've got time to do this. Right? So this is the type of thing that stops all those emergencies, all those failures, all those 3 o'clock calls in the morning in the first place. But it takes time to do that. But if your guy who's responsible for the program doesn't have time to do it, you're never going to fix the problem. You're just going to be going from one firefight to the next firefight. It's got to be done diligently and done with a purpose. And this doesn't happen in this particular mill. I'm not telling you which mill it is, but it's the pulp and paper industry, and it's not uncommon for this type of thing to happen in that industry. I'm speaking from experience. So that's example 2, not really an oil analysis program. This is example 3, does have an oil analysis program. Takes over 5,000 samples a year, which is substantial, 5,000 to 6,000 samples a year, average out $50 a sample when you look at labour costs, cost of a sample. So they're spending $300,000 plus on an oil analysis sampling program. And I haven't seen any benefits in that expenditure. If you look at the lamp components percent, it remains 50% for normal. Critical or severe is still pretty high, probably 15, 20%. Average acknowledged time, it's been up and down. They don't track any benefits, don't record identifying a problem, correcting an issue, and basically showing any improvements. So $300,000 a year, which is fundamentally a waste of money. So there could be a number of reasons for this. They're just bad at sampling or bad at fixing issues. So this is a company that thinks an ISO count of 26 is normal, which is extreme. But that's pretty typical for this type of industry. So that's dashboard example number 3, which is not what your sample should look like. So I'll explain a bit of an explanation of how powerful these KPIs are. So I would take the KPIs on a quarterly basis. I would add some case studies. I would present the management and say, this is what I need to address the issue. So I'll explain some of these numbers. You can ignore 2008. That was a turnaround year. So the plant was shut down for 2 or 3 months. But in 2009, you've gone from 306,000 barrels per day to 359,000 barrels per day. So if you quickly do the math, year on year, that's an 18% increase in production, 18% more barrels per day than they were producing in 2009. And that's because they were producing 18% more steam. So the steam goes to the upgrader cooks the bitumen, and the bitumen kind of comes out the bottom, and they put it in a barrel, and then they send it off to the refinery. No, they don't put it in a barrel, they pump it down a pipeline. So this is in northern Alberta. I'll get into this more when I explain the case studies, but it'll become self-explanatory why you've got that huge difference in production. So cost associated with this, I went to the senior management. I said, I need money for this. I needed about $5 million to make all those improvements, whether it's a lube room, filtration equipment. And included training sessions in it for the lube techs, the millwrights, because they were doing most of the oil work. So education, equipment, lube room, $5 million is a huge expenditure. But if you do the math, at the time a barrel of oil was around, I think it peaked at about $140 a barrel during this period. So it's about $100 a barrel. There was an increase in revenue of 1.6 billion. That's billion, 1.6 billion. All because of an improvement in the way they manage the lubricant. Right. So I'll dig a bit deeper into this when we get to the next webinar, because I've got some case studies which explain why that happened. And I usually get the question, I had a question from the maintenance director. He said, it can't be that simple. I said, what do you mean? He said, well, it can't be just that simple that you did this and you're seeing these results. I said, well, what do you think is going to happen if you put grinding paste in your equipment and expect it to last? So this plant was running petroleum coke, pet coke, which is highly abrasive, had lots of steam leaks, lots of water, lots of humidity. So all that was getting into the equipment and basically destroying the lubricant. I said, well, if you put clean, dry oil into the equipment, how much longer do you think it's going to last? And he's flabbergasted. He says, I can't believe it's that simple. But if it's not that obvious, if you don't do all sampling, look at the results and make the corrective actions, the first step is take the sample and have a look at it. So that's how powerful this tool is. But you need that data to get the commitment from management to appropriate the funds to fix the issues. So summarising, KPIs are all about changing behaviour. you want to tailor the KPI to the behaviour you want to change, whether it's not acknowledging a sample result for five months or never. That's a KPI. You want the analyst to be looking at the data, acknowledging it, and correcting the problem. And what I like to do is don't do a snapshot of a KPI, send it out to management and expect them to understand what it means. So I would put the report together, sit in the room with management, go through each slide and explain the benefits or what the project's about, why I need the funds, and what we're going to do to correct these issues, what these issues are. And the case studies are big as well, because then you can see individual examples of what you've done to correct an abnormal sample result and the effects on the equipment, the life of the equipment, the costs and the reliability. And ultimately, what managers like is production. So I'm going to stop the failures or prevent the failures, reduce the failures, reduce the costs and increase production. So like I said, don't send it out, schedule a meeting, sit down, explain it with the people who are going to make the approvals to POs and all that other good stuff. It's time for another question, Perry.
Yeah, I'm putting polls out there.
Okay.
Yeah, there was another comment or question here about the example with the extreme data. Was it presented to senior management of that particular company? And if so, then it's really management not understanding or not willing to change their process.
Are you talking about one of the samples, example samples? Was it one of these?
I think it must have been either this one or the one before.
Well, the short answer to that question is no.
Oh, example 3. Yeah, with the massive amount of data. Yeah.
This particular plant didn't do any of that and still doesn't do any of that.
So it was more of a failure at the reliability level rather than the management.
Yeah,
the
management.
We didn't know.
What's it called? Plausible denial. Management doesn't know anything about this, so it doesn't exist. Unfortunately, if management doesn't get involved in it and start asking those difficult questions, they're never going to know. Right? So
When I think your example, Brian, was they're spending $300,000 a year or whatever that number is on oil analysis, which is probably in the budget year on year. And it looks good because we're doing reliability tasks. But if there's no corrective action correlated to those samples, then it's just money down the drain.
yeah, it's the only guys looking at this data is the reliability analysts. Right? They're not correcting any issues, as you can see from the dashboard. Right? This is common. I see lots of, when I explain the 5 steps, like the first one is take a sample. Yeah, there's companies that take a sample, but they don't do the other steps. And if they did the other steps, they'd see the results in the dashboards. And if you did that, you might have if you followed those 5 steps, looked at the dashboards, asked for investment, you probably increase production. Not probably, you will increase production, you will reduce maintenance costs. And another thing I forgot to mention is energy consumption. If you think about it, as your equipment begins to fail, the temperature usually increases. You're basically creating more friction and you're consuming more energy. So it can be as much as 1 to 5% increase in energy costs on equipment that's running to failure rather than equipment that's running in an optimal condition. So 1 to 5% energy is a huge cost on any heavy industrial plant. So if you can reduce that cost by 1 to 5%, that's a huge savings. That more than pays for filters, oil sampling results, oil samples sent to the lab, or anything else. So even just the energy cost alone over a period of time will pay back, will pay back everything you've invested in it. But generally say any dollar you spend on improvements in lubrication has a return of $10 to $20 back. So every dollar I give you, I'm going to get 10. It's actually way more than that. It can be as much as, and as I said in this example, that's probably a return on investment of, for every dollar spent, another $30 back. And that's just in production. But to understand that, you need an oil analysis program, and you need to do the corrective actions, and you need the KPI and case studies to present to management to get that level of buy-in. And like you say, I need $20,000 for this, sign the PO, no problem, I know what you're doing with it, and see the payback. So that, again, that's a summary. I like this little slide, but if we've got any more questions.
Yeah, there's another question. Do you have a quick sheet that would show the key KPIs that should be rolled out at the start of an oil analysis program?
That's a good question, because it's a start. Assume you have no oil sample results, because if you haven't took any sample results, you've got no data to present. So that's the example I went through, which is this plant. It started small, gathered some data, presented the data, and then expanded the program. Right. So when you've got no data, your KPIs look a bit, for want of a better word, thin. But it doesn't stop you doing it. These are year-on-year samples. You could do it monthly or quarterly, divide up and saying, we're at the beginning, and this is the payback we're beginning to see. Now I need to expand the program. Right? But
yes, what about if you do have a program? Then which ones do you put in? Would it be like these 6 charts that you'd have on your dashboard?
Well, the Fluid Life dashboard button, if you want to call it that, has a whole suite of KPIs or measurements you can take from the program. So you can pick and choose whichever ones you want. So what I did with these examples is each one of these examples is slightly different. So this one has average acknowledged time, this one doesn't. The next one has test breakdowns, the other 2 don't. So you can manipulate it. What I generally do is I limit it to maybe 10 or 12 KPIs and present those. But like I say, if you're, say I put average acknowledged time, but on this one, I didn't put average acknowledged time because it's not an issue. I've changed that behavior of not acknowledging samples, right? So what's the point in measuring it anymore? It's like companies that do have PM compliance, they have a target of 90%. So if month on month I'm getting 100%, right? That's not a KPI, you've changed the behavior. So I'm not sure whether I've answered that question or not, but if we're nearly at the end of the presentation, but what I should have, if you've got any other questions, feel free to reach out to me. You can preferably email me. If I don't recognize a number, like most people, I don't answer it because I think it's a CSA, and so, or a scam. So you can reach out to me, you can email me on this contact number, and I'll be more than happy to answer some of your questions or run through some more examples.
Well, this was perfect. Yeah, we really appreciate everyone for joining in, and the interaction that we had there was great. I guess the takeaway is, it really is behavioral. That you have to want to change first, and then the next step is how you take that on. So thanks, Brian, for giving us some practical tips on how to move forward with that, and thanks everyone for joining in. So again,
yeah, thanks again for showing up. If you didn't turn up for this presentation, and even if you did, you will receive a copy of this. You can feel free to share it. But like I said, if you want to contact me, got any more questions, then feel free.
Okay, perfect. Yeah, and just another question there about the links for the next webinar. So you can find that probably on our LinkedIn page, and you might even get a follow-up from Livestorm about that as well. So yeah, stay tuned, and thanks again, everyone.
Yeah, thanks again for all your great questions, and thanks for showing up. Thanks. Bye.
Bye-bye. Bye for now.